Hey guys, it's Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines. And tonight we're looking at Calculus 1 first derivative test. So we're looking at increasing and decreasing functions, relative minimums and maximums. Let's get after it. Okay, we have several functions here. This one, if we were to take the derivative of this function here, and we found a critical value where f prime of x, or in this case we call it f prime of c, where it doesn't exist, c ends up being a critical value in that function. Now in this case, this function is saying if I take the derivative and it does exist and it's equal 0, then if that point that makes that derivative equal 0, it also is a critical value. Okay, so what does that mean? Well, if I take that derivative and I look just to on one side of c, well, I find maybe the function is f prime of x, or we'll say, is less than 0. That function is decreasing. If I look at the derivative at a certain point at x and I find that it's positive, it's increasing, well, if it's positive, that function is increasing. And you think, well, what does that really mean? Well, think about that. If I have something that I'm looking at, we have x equals c defined. So we have a critical point in that derivative, or that we take the derivative, set it equal to 0, find the value of x that makes it 0, deem that to be a critical value, and we look just to the left of c and we find we have f prime of x negative. Now if this were algebra, m is negative. Okay? We look to the right of c and we find that f prime of x, some number just to the right, it's positive. Well, if that's the case, when x equals c, that's determined to be a relative minimum. Oh, the opposite of that would be, if I have something like this, here we are at x equals c, I have a positive slope just to the left of c, and I look to the right of c and it's negative. Well, this point at c is a relative maximum. There's some power in that. Well, so let's work a problem or two and challenge ourselves to reach some better understanding here. All right, you'll see the problem in the upper right corner. It says find some positive numbers, two positive numbers, that the sum of the first number squared plus the second number equals 54. So we'll let my first number equal x. That number squared plus my second number y equals 54. Now I could, and the product of those is maximized. Well, so they're saying x times y is some product. We'll call it p. But they want p, these numbers, to be such that p is a maximum. Well, I could just say, let me solve for y, plug that in here, and then see what we can do to get a derivative then. So y equals, I'll subtract x squared from both sides, 54 minus x squared. So that's y. I'm just going to erase this guy and put 54 minus x squared, substitute that for y. Now let me multiply this out. X times 54 is 54x, minus x times x squared is x cubed. So that equals p. Now I want to take the derivative of that with respect to x. So p is just the product of two numbers. It's a constant. So the derivative of p is 0. And that equals 54 minus 3x squared. Okay? So it's set equal to 0. Let me add 3x squared to both sides. 3x squared equals 54, divide 3, and that equals 18. So x squared equals 18, but 18 can be listed as 9 times 2. If I take square root of x and the square root of that, square root of 9 is 3 times square root of 2. So x equals 3 square root of 2. So y equals 54 minus 3 square root of 2 squared. So that's 54 minus 18, and that gives me 36. Okay, so I'm going to erase this, but I don't want to lose. This is my f prime of x, we'll call it, or p prime. Let's say p prime equal 54 3x squared. Okay, and y equals 36. X equals 3 square root of 2. I think I have everything I need here. Okay, now then, you'll notice I have an interval, test value, f prime of x sign, whether positive or negative or 0, and then conclusions. So let's take an interval. Since x equals, it's this is c, that's my critical value. It's 3 square root of 2. So we want to be just one side of this. So x is greater than minus infinity, but it's less than 3 square root of 2. Okay? And test value, well, if it's a little bit less than 3 square root of 2, let's say x equals 3 square root of 1. Square root of 1 is 1. Well, okay, x equals 3. Okay, and then our next interval is going to be just a little bit greater than this. So where x is greater than 3 square root of 2, less than positive infinity. So let's say x equals 3 square root of 3. How about that? Okay, now then, we want to look at we had p prime was 54 minus 3x squared. So now we have x equals 3. So p prime equals 54 minus 3 times 3, or 3 times 3 squared. Go 3 times 3 is 9, times 3 is 27, 54 minus 27. So p prime, it's still a positive number, right? So the sign, it's not less than 0. So the sign is positive. So what do I know? I know it looks like that. So the function is increasing. It's increasing. It's something less than c, which was 3 square root of 2. Okay, so let's look at it on the other side, 3 square root of 3. So I've got 3 times 3 square root of 3 squared. Well, so that's 3 times 3 squared is 9. Square root of 3 squared is 3. So 3 times 3 is 9, times 9 is 81. So I have 54 minus 81. Well, that's a negative number. So the sign of f prime, or p prime in this case, would be a negative number. So I know on this side of 3 square root of 2, I have a negative. So negative here, positive here. So on this side, I know it's decreasing. So I know when x equals 3 square root of 2, this is a relative maximum. And that's what they were telling us to prove that that's the case. Okay, all right. To me, it's an interesting concept. All right, now we have another f of x equals x squared minus 4x. And we're trying to find a critical value, x equals c, and see if it's a relative minimum, maximum, or what. So f prime of x equals 2x minus 4. Okay, so 2x minus 4, I'll set it equal to 0. Add 4 to each side, 4 equals 2x. Divide 2 on both sides. 2 over 2 is 1 times x is x. 4 divided by 2 is 2. Okay, so x equals 2 is my critical value, and I don't need to lose my function here. So f prime of x was 2x minus 4. All right. So you can see now my interval is going to be x is greater than minus infinity, but it's less than 2. So now x is greater than 2, but less than positive infinity. Now I should note, if you have some points where the function's undefined, at 0, or like maybe there's an x cubed in the denominator, you'll have to set your intervals up to in minus infinity to 0, and then, so minus infinity here, 0 there, 0 to less than 2, and work it that way. So there may be other areas that you have to include, not just, we've got some simple problems here. So just know that there may be multiple C's in your analysis. Okay. All right, so now my test value, x is less than 2 but greater than minus infinity. Why don't we just let x equal 1? Okay, and in this case, x is greater than 2 but less than positive infinity. Let's let x equal 3. Now then, what's the sign f prime of x when x equals 1? So I have 2 times 1 minus 4. So 2 minus 4, obviously that's going to be a negative number. So I have a negative number here. All right, so now let's let x equal 3. See what happens. 2 times 3 is 6. 6 minus 4, that's a positive number. So I have a negative slope and then a positive slope. So my function is decreasing here. It's increasing on this side. So my slope was negative here, positive there. And this point C is when x equals 2. So that is a relative minimum. So in that function we had where f of x equals x squared minus 4x, you reach a minimum, relative minimum, when x equals 2. And what would y or f of x equals y equals 2 squared minus 4 times 2. So 4 minus 8, and that's a negative 4. So the point 2, negative 4 would be the relative minimum for that function. This was the first derivative test looking at increasing and decreasing functions, finding the derivatives, finding the critical value, looking then at if it's decreasing or increasing around that critical value, noting the derivative or the sign of the derivative on either side of C, and then determining if it's a minimum or a maximum. Hopefully this helps. Work as many problems as you can, and we'll have more as we go, because eventually we'll get to the second derivative test, looking at inflection points, when the things start going, changing from going up to going down. What's that inflection? And then understanding the second derivative test and what we can do with that. So Okay guys, why are we doing this? Because together we're trying to build a better tomorrow, and we're going to do that through math. So hopefully you've had a great day. Study, study, study. And that's all for now, and we'll talk to you next time. Thank you.